Good morning and welcome to a video on the 2627 review. Here's question number 1, and the directions say find the domain, the vertical asymptotes, and the horizontal asymptotes of this function. All right, well, let's find the vertical asymptote. That's where I always like to start. And we are going to set our denominator equal to 0. And of course, if we subtract 10 from each side, we get x is negative 10. That is our vertical asymptote. Now, as long as we're here, let's do the domain at the same time. Remember, in the domain, we do not want numbers that will result in negatives under even radicals, and we don't want division by 0. So there's no radicals here in number 1, so we don't have to worry about negatives underneath, but we do have a vertical asymptote, and we want to exclude that. So in interval notation, we could write negative infinity to negative 10 with a parenthesis, union with negative 10 also with a parenthesis to infinity. But that's a lot of writing. I would also accept set builder notation, the set of all x, such that x cannot equal negative 10. So vertical asymptote and domain are taken care of. Let's find the horizontal asymptote. Remember, in class I call this the power struggle between the numerator and the denominator. Highest power numerator 3x to the first, denominator 1x to the first. So since it's a tie, we cancel the x's and use the coefficients. Horizontal asymptote is y equals 3 over 1, or just y equals 3. Okay. Question number 2 here, we're going to do a little graphing. So it tells us to find the domain, identify the intercepts, find the asymptotes, plot some additional points. Well, first, let's get the asymptotes out of the way. Here is our function. And if you set the denominator equal to 0 and add 7 to both sides, you get x equals 7. So x equals 7 is our vertical. And if we look at the power struggle between the numerator and denominator, it's 1x to the first over 1x to the first. So those x to the first will cancel, and we're left with y equals 1 over 1. Oops, what the heck, I grabbed the wrong thing there. Come on, there we go. Y equals 1 is the horizontal asymptote. Okay. Another easy thing to find is the X-Intercept. Set the numerator equal to 0, and you're going to get x equals 4. X equals 4. Let me switch to blue ink. So here's an X-intercept. Now we could probably draw in this part of the graph, but let's find the Y-intercept also. And the Y-intercept is f of 0. So if we plug zeros in for the x's, we're going to get negative 4 over negative 7. The negatives cancel to a positive, and 4/7, that's a number between 0 and 1. So our y-intercept is here between 0 and 1. Okay, so if we're at the x-intercept and we start heading to the right, the vertical asymptote will force us down. If we head to the right, we'll cross the y-intercept and come in underneath the horizontal asymptote. So we know the graph is not going to be up here because it's living below the horizontal asymptote there. So we got to figure out what's going on beyond the vertical asymptote. Is our function up here, or is it down below the horizontal? So we just need to graph at least one additional point. Let's use x is 8. If we plug 8 back into the original equation, 8 minus 4 in the numerator is 4. Down in the denominator, 8 minus 7 is 1. So if we plot the point 8, 4, we'll figure out where the graph is. 8, 4 is up here. So that locks our graph in this upper part. And there's our sketch. That's pretty good. Okay, on to the next question, another graph. So let's see here, our denominator x plus 1, if we set that equal to 0, we get x is negative 1. So there is, let me make this graph a little bigger. Oops, get over there. If we set, or if we look for the power struggle, we see that the numerator is more powerful, so there is not a horizontal asymptote. But if the numerator is 1 power higher, we can divide and get the slant. So I'm going to do this synthetically, or we're going to be dividing by x plus 1. So that means we're going to synthetically do that by a negative 1. And then we have a 2 for the x squared. We need a 0 for the x to the first, and we have a plus 2 as our constant. Bring down the 2, and we multiply, get negative 2. And then we add minus 2, there we go. And then our remainder is going to be, oops, that would be a positive 2. Remainder would be a 4. But when we're synthetically dividing, the remainder is irrelevant. Here we have our slant asymptote, y equals 2x minus 2. So 2x minus 2 is a line we can graph. Let me put a dot here up negative to the y-intercept. And we're going to go up 1 over 2, up 1 over 2. I'm just going to do that a few times because I can bring over this for my slant asymptote. Oops. Come on. Oh, this thing is getting glitchy. And there we got the slant in its proper spot. Okay, next up, let's look for X-Intercepts. If we set the numerator equal to 0, 2x squared plus 2 equal to 0, we would subtract 2. 2x squared is negative 2. Divide by 2, x squared is negative 1. And when we go to square root both sides, we run into trouble because we can't square root a negative and get a real solution. So that means this graph is going to have no x-intercepts. All right, let's do the y-intercept. That would be f of 0. So the x terms are going to zero out, leaving a 2 divided by 1. That's 2. So y equals 2 is our x-intercept. If I put that dot in here, it means we're in this part of the v, so we can draw the rest of the graph. We will approach the slant, and then if we head to the left, we'll be forced up by the vertical. And now we got to figure out if our graph lives in this part or down here in the bottom part of that V. So let's just pick an additional point. I'm going to use just to the left of our asymptote is negative 2. So if we put negative 2 in for this x, it's going to square to a 4. Oops. So that's a 2 times 4 plus 2. And our denominator is going to be negative 2 plus 1. So what's that? 10 over negative 1, or negative 10. So if we go over to 2, negative 2, we're going to have to go to negative 10, which would be down here off the graph. And that locks our function graph in there. And that's a pretty good sketch. Moving on. Now we got some inequalities. So of course we got to find our key numbers and then our test intervals, and we'll test them out. So let's see here. We're going to bring over that positive 2. When we subtract it, it will be a negative 2. Less than 0. And let's see, we got to factor that. The 12x squared, that's going to break down into a 3x and a 4x, 3x and a 4x. And we would need a plus 2 and a minus 1. Plus 2 minus 1, less than 0. And let's see, for the one on the left here, we would subtract 2 and divide by 3, so that's negative 2/3. Negative 2/3. The one on the right here, add 1, divide by 4, that's positive 1/4. Do not get freaked out by the fractions, because we can use any test number we want for our intervals. So of course over here I like to use negative 10. If we put a negative 10 here, that's a negative 30, plus 2, that's negative. Negative 40 minus 1 is also a negative, so we got 2 negatives to multiply, that becomes a positive. Our positive number is less than 0. That's going to be false, so we're not going to color that section in. Next test interval, 0. Right in the middle there. We would have 0 plus 2 is positive, 0 minus 1 is negative. If you multiply a positive and a negative, it is less than 0, so that's true. And because our inequality is less than, let's use parenthesis, and we can color that one in. And the last interval, we would use 10. So let's see, 30 plus 2 is positive, 40 minus 1 is positive, 2 positives multiply to a positive, and that is not less than 0. So our last interval is false. So that's our completed graph. Here, just another quadratic. So let's see, we've got our x squared over here. We're going to add 2x to each side and minus 3 from each side, less than 0. And that's going to factor to an x plus a 3 and an x minus 1. Minus 1 less than 0. So we set the first term to 0 and we get negative 3. Oop, this pad is getting glitchy. Come on. Back up. There we go. So negative 3. The second term, set it to 0, you get positive 1. And we got to do some testing. Negative 10 is going to give us a negative times a negative, which is positive, and that's not less than 0, so false. 0 right in there would give us a positive 3 times a negative 1. Positive and negative multiply to a negative, and that is less than 0. So again, instead of parenthesis there, this is a true part of the graph. And then positive 10 will give us 13 times 9. That's a positive times a positive, which is positive, not less than 0. So that we'll leave that part of the graph uncolored in. So there's a couple polynomials. We're going to do a couple rationals, and that will be it. Oops, there we go. Okay, this one, if we set the numerator equal to 0, we're going to have to factor it. That's going to be an x plus 3 and an x minus 2. And our denominator, so if we set each of those equal to 0, we're going to get a negative 3 and a positive 2. Negative 3, positive 2. So remember, the numerator equal to 0 gives us some key numbers. And then we're going to set our denominator equal to 0, which is simply x. So 0 is also a key number. So we've got 4 intervals. Let's first look at from negative infinity to negative 3. I'm going to use negative 10 as my test, and we're going to plug it into all 3 spots. Negative 10 plus 3 is negative. Negative 10 minus 2 is negative. Our denominator x is just going to be negative. So that's a positive numerator and a negative denominator. So that's a negative answer, and our negative answer is greater than or equal to 0. False. So we're not going to color it in. Next interval is negative 3 to 0. I'm going to use negative 2. Negative 2 plus 3 is positive. Negative 2 minus 2 is negative. And we're putting a negative in for x, so that's a negative denominator. So if we multiply, our numerator is negative, our denominator is negative, and that divides to a positive. Our positive numbers greater than or equal to 0. That is true. So we are going to color in this interval. Next up, 0 to positive 2, I'm going to use 1. So up here, 1 plus 3 is positive, 1 minus 2 is negative, and we're putting a positive 1 in for x, so the denominator is positive. And that makes our numerator negative, denominator positive, and that divides to a negative number. Our negative number is greater than or equal to 0. False. So that will not be colored in. Let me switch back to, I guess, black ink for positive 10 as a test number. 10 plus 3 positive. Positive. 10 minus 2 is positive. X is just positive. So that is just going to be a positive answer. Our positive number is greater than or equal to 0. Yes, they are. We're going to color that in. Now notice we haven't done the brackets or parenthesis yet. If we look at the original, it is greater than or equal to, so you think there's going to be brackets everywhere. But remember, the denominator is never allowed to equal 0, no matter what that inequality says. So our key number that came from the denominator was 0, so 0 gets a parenthesis. The rest of it gets brackets. So it should look like this, bracket going from 2 to infinity, and a bracket at negative 3, parenthesis at 0, and there's the true parts of our graph. One more. Okay, so first, of course, we want to turn this into a single function. or excuse me, single fraction. So our numerator is x plus 32 over x minus 6. We are going to subtract the 3, and now we are less than or equal to 0. And to get the common denominator, we will multiply by x minus 6 over x minus 6. So here we are going to distribute the negative 3 and collect like terms. Our denominator is x minus 6. So here we've got a 1x, and when we distribute here is going to be a negative 3x. 1x minus 3x is negative 2x. And we'll also distribute here and get a plus 18. 32. Excuse me, that's a plus 6, right? If I back up, yeah, that's a plus 6. Okay, you were probably yelling at the computer. What the heck are you doing? So that's a plus 6 plus 6. That should be a plus. So when we distribute there, it's going to be still the negative 2x, but that's going to be a minus 18. 32 minus 18 is positive 14. Less than or equal to 0. Okay. So let's get our key numbers. If we set our denominator equal to 0, we'll get negative 6. And if we set our numerator equal to 0, minus 14, divide by negative 2, x is positive 7. So positive 7. Okay, test value time. Negative 10 is going to give us in the numerator positive 20 plus 14 is a positive numerator. Negative 10 plus 6 is a negative denominator. That divides to a negative. Is that less than or equal to 0? True. Test value 0. Numerator is going to be a positive 14. Denominator a positive 6. That divides to a positive, which is not less than or equal to 0, so that's false. Last interval, positive 10. So if we put that in there, that's a negative 20 plus 14 is negative, divided by a positive denominator. That divides to a negative, which is less than or equal to 0. True. Once again, it looks like brackets everywhere, but the denominator number is negative 6, so negative 6 will have a parenthesis. Positive 7 will have a bracket. And there's our final graph. And that's the end of the review. Have fun on the test.